when they're first learning the language. They'll write code like this and wonder why it's not calling these guys. Well, it's because this compile time resolution is the first step of the phase. It figures out what the best match is for the parameters using the compile time type. Now at runtime, well, at compile time we do that, and we make a little note that we're going to want to call add passing in tool. At runtime, what happens? The real type is safe toolbox, right? So it's going to check to see does safe toolbox actually have an add tool. No. Go up in here and call this guy. So if I came down here and I said add tool, what's going to happen at runtime? And which one is going to go to? This one up here? It'll actually go down here. So it'll call safe toolbox. Because at compile time, we figured out the signature looks like add tool. And then at runtime, we figure out where in the hierarchy it is. So we're actually going to call this guy down here. And that's what the right effect of that is. Now, if we really want these two guys to play, we have two choices. We can either change the type of this variable to be safe toolbox, or define two more methods up here, add saw and add tool, right? And now it'll resolve to the appropriate signature and then find it in the hierarchy in the right place based on the runtime type. This is not terribly intuitive. This is what it does, but it's not terribly intuitive. What people tend to think is, I defined an add saw, why isn't it getting called? If Java truly had a dynamic runtime dispatch, it would say at runtime, what's the real type of this thing? Look up the appropriate match at runtime. And that's what we're simulating here by doing this. We're saying at runtime, let me figure out what the real type of the object is and figure out where to call it. And this is something that there's plenty of times you want to do this, especially when a language looks more dynamic or feels more dynamic.